Hey there everyone, we're here to talk to you all about Le Chatelier's principle, which is a very important concept in general chemistry. Le Chatelier's principle deals with the concept of equilibrium, which is related to reaction rates. In a state of equilibrium, both the forward and reverse reactions are occurring at the same rates. Le Chatelier's principle essentially states that when a dynamic equilibrium is disturbed by an external force, the equilibrium will shift to restore its original state and neutralize or counteract the change. Let's move on to some examples explaining this crucial concept. Here's a simple synthesis reaction. Red and yellow Skittles make some green Skittles as well as some energy. This system is currently at equilibrium. Watch what happens when we add 10 red Skittles to the mix. The system shifts towards the products and re-establishes equilibrium, resulting in a net formation of 2 greens from 2 reds and 2 yellows. Next, watch what happens when we add 5 greens. The system shifts towards the reactants and re-establishes equilibrium, resulting in the decomposition of 2 greens to 2 red Skittles and 2 yellow Skittles.
Okay, thanks.
The Twizzlers represent heat. Remember how the formation of green candies was exothermic? Heat can behave as a product or reactant as well. So when we add more heat, a product, to the system, the reaction shifts towards the reactants. Pressure can also have an effect on the equilibrium. Increasing the pressure by making the blocks smaller causes the system to shift towards the products, because the one green takes up less space than one red and one yellow Skittle. The opposite is true if we decrease the pressure by making the box bigger. The system shifts towards the reactants because there is now more room for 2 molecules instead of just 1 molecule. The square candies represent solid forms of our gases. Notice how adding solid does not cause any more gas to appear in the container. This is because the equilibrium of gases depends only on the partial pressures of the gases.
Okay.